Hi guys, welcome back to another tech video. In this video, we will talk about the CPU, also known as the Central Processing Unit. If you're new here and haven't followed this Facebook page or subscribed to our YouTube channel, don't forget to tap the follow button on Facebook and or the subscribe button on our YouTube channel for more MCPL content. We bring you interesting tech videos every Tuesday, Wednesday, and Friday. In this video, we want to answer the following questions. What is a CPU? How does it work? And how do I know which CPU I have? And while answering these questions, I won't get as complicated as some of the resources out there since we're introducing the CPU into our lives for the first time. We need to date the concept for a bit before we commit. It can be overwhelming to hear a bunch of technical stuff, but we will manage. I believe in us. Anyway, for anyone who's already invested, I'll link some resources you can check out into the comments. Now, without further ado, let's do some learning. Now, this video may feel like deja vu since we're coming in right after our RAM video, and usually details about the CPU are located in the same place. So nice, easy, and efficient. Now, as I research the topics for these videos, I find myself looking up information about whether a smartphone has a tiny RAM stick, or a super small CPU chip, or a baby hard drive. When it's like, well, yeah, why wouldn't they have two out of the three of those things? And they're essentially handheld computers. But then I go, well, was a Palm Pilot considered a handheld computer? I've never seen one. I don't really know how those work. And then my ADHD just kind of spirals and I move on. But to answer our curiosity, just like smartphones have RAM, they also have CPU, but no hard drive. So, let's move on again. Back on track. Alright, if you've shopped around for a computer or smartphone, you may have seen the specification cards next to each device. These cards list details about a device's build to help you choose between multiple options. You'll probably see a bit of information on these spec cards, and some of it may be important to you, like storage capacity, processing speed, system memory, operating system, screen size, screen resolution, battery life, and so on. And since this video is about CPU, you may also see it referred to as a processor model. So what is that? The definition of a CPU is the central processing unit of the computer. A computer's CPU handles all instructions it receives from hardware and software running on the computer. So as an example, the CPU processes the instructions to use a web browser or an app to open and display this page to you on your computer or smartphone. Now, CPU stands for Central Processing Unit and is also called processor, central processor, or microprocessor, just to be more confusing. Now, I'll be calling it the CPU or the processor while we're together. Now, before we move on, you may have noticed that the information tip on this screen compares the CPU to a brain. It says your computer's processor is like its brain. Working in combination with system memory, the power of the processor determines the complexity of software you can run, how many programs you have open at a time, and how fast those programs will run. Most computers feature an Intel or AMD processor. So if you want to think of the CPU as the brain of your computer because that's better imagery for you, definitely do that. But it's a little bit more appropriate to refer to the software as the brain, and the CPU is a very efficient calculator. A CPU is really good with numbers, but if it wasn't for the software, it wouldn't know how to do anything else. In our devices, there's a bunch of different internal pieces that make the external pieces work. Internal pieces include a motherboard, which is a type of circuit board that holds other important components. There are a ton of metaphors that we could use to help us understand how the motherboard works with the CPU, the RAM, the hard drive, and the GPU, and other parts of the computer. So let's think of the parts of the computer in an office setting again. The motherboard was the desk in your office or living room. Whatever work you do is done on this desk. It has drawers and slots for paper, folders, snacks, and so on. So where does the CPU fit on your desk? Well, the CPU is you, sitting at your desk where you work. You figured out what needs to be done and how to do it. And you can only work on so many things at once in this space, but you can work pretty quickly. Now, without you there to do the work, nothing would happen. If your computer didn't have a CPU, it would not work. if you had a CPU but no hardware, then no work could be done. You cannot have a CPU without electronic hardware and vice versa. The CPU works with your software to take an input, process it, and then produce an output. So let's talk about inputs and outputs. All computers do these four things: input information, store information, process information, and then output information. These steps are done by different parts of the computer. Inputs are part of the physical world that give information to your computer. So your keyboards, touch screens, microphones, cameras, scanners, sensors, and so on. These input devices convert physical input into binary information for your computer to understand. So remember from our encryption video, the binary code is computer language in binary digits of zeros and ones. The memory stores this information, and the CPU calculates the information. From there, output devices receive information, converting it from binary to a physical output. So your output devices are your monitors, printers, headphones, speakers, projectors, and GPS, and so on. Now, a human brain can process information at 60 bits per second. And that's according to a bunch of psychologists who are way smarter than me, so I have no reason to doubt that number. Now, I say that because our brains process information 10 million times slower than a computer. So that's why this input, process, output cycle seems staggeringly fast, because it is. Your CPU can only complete one task at a time with every tick of the clock, but different CPUs calculate at different speeds. So some are able to complete one instruction 1 billion times a second. Now that may sound incredibly confusing, but it'll make sense in just a moment. So how fast a CPU does this depends on the CPU's clock speed, cache, and core. Now I know I've thrown everything at you but the kitchen sink, and the kitchen sink is coming. So let's take the list of things and break them down. How does a CPU work with inputs and outputs? What is clock speed, cache, and core? When you press a key on your keyboard converts that letter into a number. So if I wanted to type the letter B for Brittany, in binary digits, the letter B is 0100000010. And I hope that was enough zeros. Either way, it's on the screen. So your CPU then has to calculate how to display that information pixel by pixel, but it is not great at remembering everything. It has way less built-in memory or cache than your RAM or hard drive. So the cache built into your CPU asks the RAM for the instructions on how to display the letter B, pulling that information and predicting any additional information that the CPU might need. So the CPU can now run the calculations for how to draw the character, and then it'll store that information in memory. Finally, this information is sent to the output device, who converts the binary information into what we see on the display. So how does this work behind the scenes? So the software tells the CPU what it needs, so the CPU has to figure that out by following an instruction set, which is a list of actions the processor performs, including adding numbers, comparing two pieces of data, and moving data into the CPU. So these instructions tell the CPU to fetch, decode, and execute, which it does so in stages. So the first stage is fetch. So you get the instructions from memory, and then you'll sometimes store this information in the cache to recall immediately later. So this just means that the CPU has to go, okay, I need to do this. How do I do that again? And then once it has those instructions on how to do that, it'll decode them, meaning it'll get the appropriate variables needed for execution of the instruction. Then what it'll do is actually do the instruction, so it'll compute the result of the instruction. And then what it'll do in these last two steps is memory and write back. Memory is where it will, for instructions that require a memory read-write operation to be done, it'll do that at this point in time. And then it'll do what's called a write back. So it'll write the results of the instruction back into memory. So what this means is the CPU will try to learn to remember how to do this same instruction set again later, so that way it doesn't have to pull that information from the RAM or the hard drive. Now, nearly every instruction goes through the first 3 and final steps in the set. Only certain instructions will go through the memory. Now, if the software is the brains of this operation, why does it get to tell the CPU what to do? Now, that's thanks to the operating system. It works hand in hand with the CPU to make sure that the fetch execute steps are completed in order, but it also controls quite a bit more than that. The operating system is the master program that manages how software uses the hardware of a computer. It allows you to install new programs, load them into your computer's memory, and then decides which program the CPU will run. It also decides which programs have access to the input and output devices. So when you're ready to open a program, the operating system finds that program in the storage files, loads it into the main memory, and instructs the CPU to start executing the program at the beginning. Now, if you need to open another program after this, your operating system makes this possible. Remember, even if the operating system and the RAM let you multitask between programs, the CPU can only execute one task at a time. So how does it work around this? When you have multiple programs open at once, they are in one of 3 states. They're either running, waiting, or runnable. So if it's running, this means that the CPU is working on this process's instructions. It's using one of its available cores to execute an instruction list. So the fetch, execute, decode, and write back. If it's waiting, the process cannot run at the moment because it's waiting for some resource to become available or for some event to occur. So for example, the process may be waiting for keyboard input, disk access request, inter-process messages, a timer to go off, etc. If it's runnable, that means it's in the state of a process that is ready to run. So it has the instructions to execute, and it's not waiting for an input or output to be completed. But it isn't actually running because some other process is on the CPU at the moment. So runnable processes are kept in queue by the scheduler, so your operating system. Usually it keeps it in a separate queue for each priority level. So when it's time to select a new process for execution, the scheduler finds the highest priority, non-empty queue, and selects the first process in that queue. So that just means that the operating system decides, hey, this one's the one that you need to do next, CPU, go ahead and get it done. Now, there are way more processes than this, but these are just the ones that I'm highlighting. So you get the idea that the operating system puts things in order for the CPU and says, hey, you need to work on this one. Okay, now they want this one, so work on that one, and so on and so forth. So your operating system works hard to swap between programs as you decide how and where you're going to multitask. So it'll decide the best way to switch between all of these processes, since only one process can be running at a time. So the operating system has to use a scheduling system to decide which program is in what stage at any point, including the CPU when it needs to. Now, some of these scheduling algorithms are first come, first served, priority scheduling, or round robin. So first come, first serve means whichever program is added to the queue first is run until it finishes. Then the next program in the queue is run, and so on. So if you opened Word first, then your internet browser, and then you opened up a messaging app, it's going to load Word first before it'll move on to your browser. Now there's priority scheduling. So the operating system assigns each program a priority. This could be based on how much memory they take or how important they are for maintaining a responsive user interface. The program with the highest priority is picked to run next. So this could be if you've opened Word but you've clicked off to your browser, it'll probably load Word in the background, but it'll take priority for your browser since that's the one that you have active at the moment. In round robin, scheduling time on the CPU is divided into equal parts called time slices. Time slices are allocated to each program equally and cyclically. This means that if we had a list of 3 programs running, the CPU would run program 1 for 1 time slice, program 2 for 1 time slice, and program 3 for 1 time slice. Now, like with these process states, there are a few more scheduling algorithms than these, but you kind of get the idea. The OS decides which program is running, waiting, or runnable, giving each one to the CPU for processing time in either a first-come-serve, round-robin, or priority scheduling. Now, these instructions are completed at such a rapid speed that it feels instantaneous. How fast a CPU can complete one instruction depends in part on its clock speed. You'll also probably see this referred to as a clock rate, but a clock speed is how fast a CPU can carry out instructions. So a CPU can calculate input information and output that information with each tick of the clock. So with a clock speed measured in cycles per second, where a cycle is a basic unit that helps understand a CPU speed each time it fetches input and executes output, and one cycle is known as a hertz, a CPU with a clock speed of 2 gigahertz can complete 2 billion cycles per second. Or a CPU with a clock speed of 3.2 gigahertz executes 3.2 billion cycles per second. So a higher clock speed means a faster processor. Most of the time, individuals that build like gaming computers, they want a higher processing speed for their CPU because it'll load games faster and then render objects faster. So hopefully that made sense. Clock speed is measured in cycles per second. A cycle helps us understand the speed of how fast a CPU fetches input and executes it. And it can do that 1 billion times a second. Fetch, execute, over and over and over, every second. So as you can imagine, something that's doing billions of calculations at almost the speed of light can generate quite a bit of heat. A CPU is a small computer chip attached to the motherboard underneath a heat sink and a fan to dissipate heat away from the CPU. Because if your CPU gets too hot, it can become unusable and even damage other parts of the computer. So heat sinks and fans also cool the GPU, other chips that may be on the motherboard, and the RAM with the help of air. And then side note, you can use different cooling methods. There's air and then there's water cooling. So you can explore those methods if you're building your own computer or upgrading. Now, we've talked about the CPU and how it does calculations, but how do you know what processors to keep in mind? First, you need to know about the architecture behind most CPUs and how they're made. So we touched on this just a moment ago, but a CPU is a small computer chip. It's actually a package containing the processor sealed inside of a metal container. This fits into a socket on the motherboard with a cooling method attached to that package. So when you look at the top of the chip, or on a spec sheet if you're in the store, you may see some information like Intel 10th generation Core i5, Intel Celeron N4020, 1.10 gigahertz, AMD Ryzen 5 5000 series, Qualcomm Snapdragon, and so on. And then you'll see a section below that processor name with the model number, and then you'll also see a section that says cores. So remember, part of what makes a CPU work and things we consider part of the CPU to be its clock speed, its cache, and its core. So clock speed, how fast it fetches and executes data. Cache is its built-in memory. And now the core. So typically we want a computer that's going to react quickly to the instructions we're sending it from our input devices. We know that the clock speed's how fast the CPU can fetch information from the cache, decode it, and then execute an output. But how and what does a CPU core do? To run and launch the apps you use, a CPU is going to need more than one core or brain, because we usually multitask between apps on our phones and computers. CPU cores are the pathways made up of 1 billion microscopic transistors. Transistors? There we go. We'll try that word. That pronunciation. That's the one. Within a processor that help make it work, receiving instructions and performing calculations or operations to satisfy those instructions. More than one core can help complete one instruction at a time, helping you do more than one thing and have more than one program open at a time. Some programs require a bit more processing energy from the CPU, so having more than one core helps delegate resources when and where they're needed to keep your computer running smoothly. More cores means that there's more instructions that the CPU can take from the operating system to complete tasks, process tasks faster. So some devices have 2, 4, 6, 8, or more cores within the CPU package. The more cores you have, the easier it is to work on more tasks at once. So if you're using your computer for basics like word processing, emailing, internet searching, playing music, and the like, a dual core processor or 2 cores would suffice. And as you start to use apps or play video games, you'll probably need a little bit more power from your CPU, as video editing, audio editing, 3D rendering, processor-intensive games, graphic design, and so on require way more processing power, more RAM, and a dedicated graphic card. So you'll want higher core numbers for those tasks. Now finally, how do you figure out which processor you have in your computer? Let's start with our Windows PC. When you are ready to access your settings to check out your CPU model, you'll click on your Start menu on the bottom left-hand corner with your Start icon, and then you'll go to your Settings. And then from Settings, you'll want to find System. Scroll down to About. And then underneath your device name, under Device Specifications, you'll see where it says Processor. And so mine says that this is an Intel Core i5 6300U. So it has 2.4 gigahertz, meaning you can do 2.4 billion cycles per second. Now, if you wanted to see how much of that is being used currently, you'll close that and access the Task Manager, or you can either do Control-Alt-Delete and choose Task Manager, or right-click on your Start menu and choose Task Manager from there. And once it comes up, you'll want to make sure you are in the Processes tab, and then you'll have a tab that says CPU, and as it updates, it'll change as it realizes how many processes you have open. Because some processes are working in the background, so they're actively updating. So you can click to sort it, so it'll show you the highest thing taking up the most CPU at the moment. And mine's doing a lot of jumping around, doing a lot of stuff. But yeah, that's how you'll check that. And then if you find that something's not responsive, maybe you'll click on whichever one. Oops, there we go. And then you can end the task. That way it'll free up some CPU to delegate to something else. But I would only do that if something's unresponsive, as in it got hung up in a process. So that's how you do it on your Windows 10 PC. And now on to the Mac. Ready on your Mac to check out which CPU you have. You'll access the Apple logo in your menu bar. Oops, and then choose About This Mac. And then what you'll see underneath the type of your model, essentially, is a processor. So mine says 3.5 gigahertz dual core Intel Core i7. So like we learned a minute ago, 3.5 gigahertz means it can do 3.5 billion cycles per second. Dual core means it has 2 cores. Now, if you wanted to see which programs you have that may be taking up CPU as you're using it, you'll close that. I already have it open, but you'll open your activity monitor. I'll show you how to get to it. So in your menu bar, you'll choose Go, and then click Utilities, And then activity monitor is the first one. And you'll see in the kind of upper right hand corner, there's a tab for CPU, memory, energy, disk, and network. You'll want to make sure you're in the CPU tab. Now you'll see that it'll have different process names here, and then a percentage of the CPU that the different apps are taking up. You can filter that by clicking on it. So right now my activity monitor is taking up 25% of my CPU. And then toward the bottom, you'll get some readouts. You'll have system, user, and idle, CPU load, and you'll have like a little, I'm sure there's an official name for these, but I always call them Dopplers, but that's probably not right. And then threads and processes. Now, we didn't talk about threads. We talked a little bit about processes, but that's another facet of CPU for deep dive learning. But that's how you get to your CPU information on your Mac. Alright, so that's what I have for you today. Today's video was brought to you by the letter B. You're awesome for sticking with me. I hope you've learned a lot about the Central Processing Unit, and thanks so much for being here. You'll want to definitely watch out for more videos from us. The next video in our What is Tech series will be about GPU. So come learn about what GPU is and how it works for you. Have a good day. And we want to thank you for watching. Follow us to find more videos just like this. Our page on Facebook is MCPL 360. We're here every Tuesday, Wednesday, and Friday. And if you miss us on Facebook, you'll still find these same videos on our YouTube channel at MCPL Mo. Find our Consumer Technology playlist. Have a good day.